Hello, everyone. We are Whoosh Solutions, and we are Ben, Grace, Neil, and me, MaCris. We were commissioned by the company Burket through Eskwelabs to develop a product category recommender engine for their request for quotations or RFQs. Let us introduce you to our client Burket.ph, whose company name is a contraction of the words business and market. It is an e-procurement platform that links buyers to suppliers. For the project, we'll focus on the request for quotation or RFQs of buyers. This is the interface for that. Through the RFQ page, buyers get to initiate their search for suppliers. Burket matches buyers to suppliers based on the information provided by the RFQs. Potential suppliers are then presented to buyers based on their match. At present, users manually input the product categories, which serves as one of the bases for suggesting suppliers. They have their own product categorization as their user inputs. Once they have the RFQ, they manually categorize the RFQ into the Google Product Taxonomy or GPT before matching them to suppliers. But this disconnect workflow or method is prone to errors and has delay in terms of connecting our buyers to suppliers. While GPT or Google Product Taxonomy, it recognizes that a particular set of products is suitable for a specific shopper with the aid of their taxonomy. Thereby, it arranges the product ads and thus results in smooth functioning. So our main objective is how we can automate and accurately categorize requests with minimum human intervention. So our project is to develop this recommender engine that suggests possible product categories to request for quotation made in the Burket platform. These categories should match with the GPT. We start by exploring the data. We noted that the increase in RFQs coincided with the start of 2020 pandemic, which is around April or May. 2021 RFQ levels are already comparable to its pre-pandemic levels. We also did topic modeling of the RFQs. We generated 4 main topics: invitation to suppliers, asking for specific items with requested characteristics, and the focus was mainly on pandemic years. The word cloud emphasizes the pandemic items requested through the RFQs.
Examining Burket's data, we observed 2 main issues. First, the provided data by Burket has no GPT label. And this is important to us since GPT label is the one that we are trying to predict. To fix this, we use Whoosh API to identify GPT categories of the given dataset. Here, we can see an example of categorization. Columns in black are the user's input, while column in yellow is the output of Whoosh API. Just to reiterate, we only use Whoosh API since our data is incomplete. And it is important to note that this method does not guarantee 100% accuracy, since output is dependent on the user's input. The second issue that we identified is the size of the dataset, which is relatively small to train our model. So, we augmented the dataset using PhilJobs, a procurement system of the Philippines. But we found out that PhilJobs data has a wider scope in a different format and has no GPT label. So we tried to filter the data to only those that are related to Burkets.
So those were the steps we took for the data completion part of our data pipeline. Once we were able to complete our data set, we performed necessary steps in processing textual data, namely tokenization and removal of stop words. We also label and coded the general Google product taxonomy categories. With the structured data in place, we performed count vectorization to examine frequency of words as features to be used in the model, and TF-IDF transformer to add importance of words as again another feature that our model can use in classification. In other words, in the data processing and feature engineering stages, we wanted to make sure that our data was converted to numerical inputs by checking what words are associated with specific categories. And those inputs can be used by the model to make decisions. We then used 2 algorithms appropriate to classification of textual data, namely SVM and naive Bayes algorithm. We calculated accuracy metrics and selected the best model that classified quotations to the umbrella GPT categories. After the initial classification, we used NLP text similarities to check for specific GPT categories. A recommendation engine was put in place, which suggested top 3 specific GPT categories based on those inputs. Our training set is a combined data set from Burket and PhilGeps, and comparing the accuracy scores generated by the naive-based model and the support vector machines model, it is very much apparent that the SVM classifier is the better choice. Our model is able to classify requests for quotation to the 19 umbrella Google product taxonomy classifications represented in the dataset with over 90% accuracy using SVM. We use the identified general category with the RFQ entry as inputs to a recommender engine, which suggests specific Google product taxonomies based on text similarity. The top 3 most similar were recommended as the specific categories under the Google product taxonomy. And to illustrate, after a buyer types the quotation details in the RFQ form of Burket, our model will identify its general Google product taxonomy categorization. The general GPT category, and with the other RFQ details will serve as inputs into our recommendation engine, which suggests specific GPT categories using text similarity measures. So Burket doesn't have to manually tag the RFQs. Our recommender engine will do this for them, and specific categories can then be used as basis for suggesting suppliers.
So to give a recap, the product category recommender engine we used is the Whoosh API to generate the GPT product categorization that is used to train our model. And out of the models, the best model was the SVM, which was able to classify a product's umbrella category with over 90% accuracy. To evaluate how helpful the recommender engine is in improving user experience of processing quotations, it is important to monitor how long does it take for a user to process a quotation with and without the recommender engine and see if there are improvements in the processing time. And this can be done by monitoring changes in average time to process the RFQs. To further optimize the model, it is important to retrain the model with more entries and categories for a more holistic representation and accurate classification of all the GPT categories. We have the following recommendations to help our model smarter. So first, it would be best to have a dataset that is correctly labeled with Google Product Taxonomy, as the dataset we used to train was only generated by the Whoosh. So it would be better to have the Burket dataset with the RFQs and their correct product taxonomy. Second is to use correct and validated dataset to retrain the model and improve its classification capacity. And finally, we would also like to recommend to consider adding fields where users can add additional attributes of the product for more specific order details and enhance the accuracy in generating categories. And having said those, we believe that our model can spur Burket as it evolves into an even smarter platform where buyers and sellers can meet. Burket has already built a structure and space where these two can meet, and with our solution, we hope they'll be able to meet as soon as they can. And with that was Qlassify, our RFQ category recommender engine for Burket. We thank you.